This is the second video on functions, and we're just going to write a few more. So let's go below our main function here, and the next one we're going to write is going to be one to find the square of an integer. So it's static, remember, for all of these console functions, and it's going to find the square of an int. So that means it has to return an int, which will be the square of that number, and we're just going to call the function square. We'll pass in a number, and again, with generic functions like this, it's very hard to come up with a descriptive name. So we'll just call it n, and we're getting the red underline because there's no return statement yet. So I want to return, that's spelled right, n times n, semicolon, and that will give us the square of the number. Now we need to test it. And this time I will put the plus sign in there, and the name of the function is square, and we're going to pass in the number 5. Need a semicolon on the end, and we should be good to go. So we should get a 25 printed out this time. When we do, everything works. Let's go ahead and close the console window. Now we're going to try something. We're going to try changing this to 5.0, which makes it a double. I can put an F on the end to make it a float. Either way, I'm getting an error message, and C#, remember, is a strongly typed language, and what that means is that data types have to match up correctly. So this is a floating point number, and down here it says it cannot convert from float to int. So this is a floating point number. This is expecting an int. You can't stuff a floating point number which could have a fractional part. Now it turns out here that the fractional part is 0, so theoretically this would work. But in general, we don't know. So since we don't know, we don't allow floating point or doubles to be passed to a function that's expecting an int. You'll always get a compile error when you do that. Okay. Now, let's. I'm going to change this back to a 5, and our error messages go away. Now we're going to go down here. We're going to make a little change. We're going to make this a float. And here we're going to make this a float. So it's expecting a float to be passed in. Up here I'm passing in an integer. An integer is not a float, but one of the exceptions, maybe the only exception, to this strong typing is we do allow an integer to be used or passed in any place where a float or a double is expected. The reason for that is simple. You can convert an integer into a floating point number without losing any of the fractional part of the number, because the fractional part is always 0. You can't go the other way around. You can't convert a floating point number into an integer without risk of losing the fractional part of the number. So the one exception to this type matching up is that if we pass in an integer where it's expecting a float, C# does allow us to do that. So this is still legal C#. So if you're doing functions that do calculations on numbers, it might be better to have them do floats or doubles. I'm used to using floats now because we use floats in monogame all the time, but actually if you want more precision here, you would use a double. And so if I change this to double, let's actually do that, and change this to double. Now I can pass in anything. I can pass in an integer, I can pass in a floating point number, or I can pass in a double, and it will all work. So this is probably the best way to do it. Let's try, let's go back one here, and let's make this a float, and let's see what happens if we try to pass in a double to a float, and we get an error here too. And the reason is a double precision number has basically twice as many digits of precision as a floating point number does, and if we convert that into a floating point number from a double, we're going to lose the actual numbers like 7 or 8 decimal digits of precision. And C# doesn't want us to do that without knowing for sure that that's really what we want to do. And the way that we tell it we really want to do that is we can convert this into an int, or we can convert it into a float. And either way, a float or an int will fit into a floating point number. A double will not fit into a floating point number. And those are the rules for passing in numbers as arguments to a function. Okay, let's write another one. This one is going to be we're going to use doubles for numbers, I think, from here on out, at least for most of them. And this one's going to be rectangle perimeter. We're going to pass in, if I want to know the perimeter, I need to know the length and the width. So we're going to pass in a double called length, and this time it does make sense to give them descriptive names, because if we're dealing with a rectangle, those are the only two numbers we're going to have. So, and the perimeter is the length plus the width plus the length plus the width. So it's going to be return, and we'll do 2 times the length plus 2 times width. Okay. We got a return statement in there now, so we don't have to worry about any errors here for not having a return. And we're passing in doubles, we're returning a double, and now all we have to do is figure out what we're going to call it with. And here we call rectangle perimeter. And it does come up and say that it's expecting the length first and the width second. And in this case, so, technically the length on this is 7 and the width is 5. So the order, that's the order they should be in. However, since all we're doing is taking each one and multiplying by 2, the order in here doesn't really matter. If we turn them around, we'd still get the same answer. Let's go ahead and run this. We should get 24. And we do. Let's go ahead and close that. Now let's write another one. We're going to write a function called circle area. So let's do static, double, and the only thing you need to calculate the area of a circle is the radius. Getting the red wavy underline because I do not have a return statement that returns a double. And now I've got the return statement, and so it's getting rid of the red wavy line. What I want to return is the radius times the radius times pi. Okay. Now pi is 3.14159. That's all the further I've got it memorized. That's probably pretty good. 5 decimal digits of precision. And we need to call it from up here now. So let's do console.writeLine. And we're going to call circle area. We're going to pass in 5. And again, it doesn't matter that we're passing in an integer because an integer will fit into a double. So let's go ahead and run that. And we should get 5 times 5 is 25. And if you multiply that by 3 and approximately 1/7, we'll get 75. About 78 is what we should get for an answer here. So let's go ahead and run that. And we get 78.5395 or 75. So we're good. If we want more digits of precision, we can use the built-in math module .pi. And notice that is both letters are capital letters. So that's a built-in constant in the math module. And let's go ahead here and run that. We should get quite a few more digits of precision. Usually get about 15 digits of precision when you're dealing with floating point numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we get the number with just a little bit more precision there. So let's go ahead and close that. And let's stop this video here, and we'll continue with functions in the next video.